Okay, starting in on chapter 4, we're looking at the 4.1 study guide, and we want to be able to classify triangles in two different ways. We want to talk about classifying triangles based on what their angles look like, and then also based on what their sides look like. Okay, every triangle, by nature of its name, triangle, has three angles and it also has three sides. Okay? So if I want to classify the triangle by its angles, I can think of it in terms of ways that we've already studied angles. We have acute angles and we have obtuse angles. Okay, with an acute triangle, all three angles are acute. Really pretty simple. Okay, it would look something like that. Okay, they don't all have to be equal to each other, but they're all less than 90 degrees. Now, for an obtuse triangle, it would be impossible for all of the angles to be obtuse, right? An obtuse angle is greater than 90, so as soon as I have two of those that are greater than 90, the sum of the angles in the triangle will be greater than 180. So in an obtuse triangle, there's just one obtuse angle. Okay, so we look for that one obtuse angle, and then we classify that as an obtuse triangle. So just not to be confused, there are going to be two angles in an obtuse triangle that are acute. They have to be. Okay, so when I look at this obtuse triangle here, it's obtuse. I would say it's an obtuse triangle because it contains an obtuse angle, and that's that. This triangle here, since it is, you could say that it's acute, but we're going to describe that more specifically and say that it's equiangular. If every angle is equal to each other and they're all 60 degrees, that's a little bit more specific type of a triangle. And then finally we have a right triangle. If there's a 90-degree angle in there, and we've seen that concept before with perpendicular lines, if there's a 90-degree angle in there, then we simply say it's a right triangle. Again, with the right triangle, remember the other two angles will be acute. So in order to classify a triangle as acute, all three angles have to be acute. Okay, so let's work through some of these and also answer them in the Edpuzzle as well. So in the first one, I have four options here as to how I would answer this. I'm either going to say that the triangle is acute, equiangular, obtuse, or right. So in the first one, I'm going to draw my attention right away to the 90-degree angle. As soon as I see a 90-degree angle there, I know that that triangle is a right triangle. It doesn't matter to me that the other two angles are acute. It's going to be a right triangle. Okay, in number two, when I take a look at this one, immediately I look for that obtuse angle. If there's an obtuse angle there, it doesn't matter that the other angles are acute. This is an obtuse triangle. Okay. Number three is a very special case. In number three, we have 60 degrees, 60 degrees, 60 degrees. All of the angles are equal to each other, so this is a equiangular triangle. Okay. Now we go to number four. I don't see a 90-degree angle in there. I don't see an obtuse angle in there. All I see is three acute angles, so this is our acute triangle. Remember, all three angles have to be acute. Number five, what do I see right away? A 90-degree angle. Even better. Remember, your symbol for perpendicular or 90 degrees is that little square. Okay, so this is a right triangle. Okay, and then finally, I look at an acute angle. Acute angle, this is not an acute triangle because I have one obtuse angle. It's just a little bit bigger than 90. It's 92 degrees. That's an obtuse triangle. It has an obtuse angle. So in the second part of our lesson, we're now going to classify by side. So we want to pay attention to the directions. So they ask us to classify the triangles by sides. So if they're asking me to classify the triangle by sides, this equilateral triangle is also an equiangular triangle. If I look down here, all of these angles would be equal as well. But if they ask me to classify it by sides, I will not say that it's equiangular, even though it is. I'll say that it's equilateral because they're asking me to classify it by its sides. Okay, what we have here are two sides equal, so it's 2/3 of the way to being equilateral or equiangular, but it's not equilateral because we're missing that third side. In that situation, this is an isosceles triangle. Right? It's like a Dorito. If you're a fan of the Dorito chip, that is generally how they're shaped. They're isosceles triangles. Okay? And the last one, we might be tempted to say, oh, this is obtuse, it's an obtuse angle. But again, remember, we're locking in on the sides. What happens when none of the sides are equal? This one's 12, this one's 15, this one's 23. Not a single one is equal. This is what we call a scalene triangle. So we have three ways that we're going to talk about these triangles by their sides. We're either going to say that all the sides are equal, they're equilateral, or we have two sides that are equal, that's an isosceles situation, or we're going to say none of the sides are equal, this is our scalene. Okay, so let's try some of these and put our answers in the Edpuzzle as well. So in the first one, I have a side that's equal to 1, square root of 3, and 2. Not a single side is equal there, and if I don't have even a pair of sides that are equal, this is our scalene situation. Okay, and number 2, what happens? Every single side is 18. They're all equal to each other. This is not equiangular. Use the terminology for sides. This will be equilateral. Okay. We're either going to say that it's equilateral, isosceles, or scalene in this situation. Okay. Let's focus on those descriptions right here. One of these three. Okay. Now I have 12, 19, and 17. None of those are equal to each other, so this is a scalene situation. Number 4, they don't give me any values for the sides. I don't know what they're equal to, but they do show me that SW and SU are equal, which means I have two sides that are equal. When two sides are equal, this is my isosceles triangle. Okay, number 5. No numeric values, it doesn't matter. I know that 32x is equal to 32x, and it's not equal to 8x. So I have two sides here. If two sides are equal, that's isosceles. And then finally, number 6. Again, I don't know what x equals, but I know all three sides are equal to x. If all three sides are equal, this is an equilateral triangle. So lastly, like what I'd like to do here is apply some algebra to these types of triangles. So we're going to do two things. We're going to find x, and then we're going to find the length of each side of the triangle, RST. And they tell us right away that it's an equilateral triangle, all right? So that means all three sides are equal. So any way I want to solve for x, I can. I can say that 2x plus 2 equals 5x minus 4. I can say that 2x plus 2 equals 3x. I can say that 3x equals 5x minus 4. So we can choose right from the start which one of these we believe is the easiest way to solve for x. I like this one. It just seems like there's going to be less for me to have to do in that situation. So what I'm going to do here to solve for x, if I have 3x is equal to 2x plus 2, it's just one step. I'll subtract 2x from both sides. And right away, I find that x equals 2. If you had solved either of the other equations, it might take you more steps to get there, but you will indeed find that x equals 2. So that's step 1. Okay, step 1 was solve for x. Step 2 is find the length of each side. Well, it's equilateral, so every side is equal. So if I find one, I find them all. This is 3 times 2, which is 6. If you don't believe me, 5 times 2 minus 4 is 10 minus 4, which also is 6. These are all going to be 6. 2 times 2 plus 2, that's 4 plus 2, it's 6. But you don't have to fill them all in. You don't have to solve them all out. As soon as I find one and I know it's 6 and it's equilateral, I will find them all. Okay. In the next one, what happens here? Here we have an isosceles triangle, so here we have to be careful. I can't just say, well, 4y could equal 3y. That's wrong. Okay? They're not telling me that. What they're telling me here is it's isosceles, specifically AB and BC are equal. So there's only one equation I can possibly set up here, and that would be that 4y is equal to 3y plus 2. I have to use that equation. And then to find the length of each side, I will have to plug back in. And be careful. I know that two of the sides will be equal, so I'm going to subtract 3y from both sides, and conveniently we get y equals 2 again. So I'm going to do the same thing though, but I have to be careful. This is 3 times 2, which is 6. But I cannot assume the other two sides are 6 because they're not. But they should be equal. So this side here is 4y, which is 4 times 2. So that side would be 8. Now I can go ahead and assume that this side is 8 because they're isosceles. But if you want to check, this would be 3 times 2 plus 2, 6 plus 2. Indeed, it's 8. So the lengths of my 3 sides there would be 8, 8, and 6.